Here we are in section 4.7, and this is quite a review because we are talking about antiderivatives. And so we have been introduced to this some time ago, and so here we go again. We begin with finding the antiderivative of the given function, and just like always, um, the big problem here is making sure that we don't forget the one little thing that I often do. So the first thing we're going to do is rewrite this in user-friendly form. So that's 7x to the 1/2 power plus 5. Now when we take the antiderivative of this, what we do is we put what was already there and we do the exponent first. But instead of subtracting 1, we're going to add 1. So here 1/2 plus 1 is 3/2. And then we have to divide, instead of multiply by that number, divide by 3/2, and then here where the derivative or the variable is x to the 0, so we add 1, get 5 to the x. Then we just clean this up, and this becomes, what, 14/3 x to the 3/2 plus 5x, and then we want to put it in a more acceptable form. And so we get 14/3 the square root of x cubed plus 5x. And just like I said I consistently do, I keep on forgetting the plus c. So don't forget to do those plus c's, and then everything will turn out just fine. Number 2. Number 2, we have 4 cosine of 6x. And so, once again, we leave what's there to take the derivative. The antiderivative, well, the derivative of cosine is negative sine, but the antiderivative is sine, because if we take the derivative of sine, we would get cosine. That'd be sine of 6x, but then we have to divide by the derivative of this inside, or 6. And then clean plus c. Do not forget that plus c. And then just cleaning it up, we get 2/3 sine of 6x plus c. This one is rather simple in this particular situation. Now 3 and 4 actually give us the symbol that we get to use for it, and that is this very long sigma is what it is. And this is saying take the antiderivative, or the integral of 1 over x to the 5th minus x to the 5th minus 1/4, and we have to tell what variable we want to take the antiderivative with respect to, and that is x. Now this is going to play a very big part coming up here in a future problem, so be sure to keep that right there. Okay, first thing I'm going to do is to rewrite this in a user-friendly form. So this becomes x to the negative 5th minus x to the 5th minus 1/4 dx. Now I can actually take the antiderivative, and that will become add 1 to this, so I get x to the negative 4, and divide by that new exponent. This becomes x to the 6th, and divide by that new exponent. And here, since it was a constant, it's going to become 1/4 x plus c. Now all I have to do is to clean this up, and then I'll be done. So this becomes negative 1 over 4x to the 4th minus x to the 6th over 6 minus 1/4 x plus c. And that is the final answer for number 3. Number 4 is very similar. We're going to take the antiderivative of negative 8 cosine of t with respect to t. Well, the antiderivative of cosine is sine. There's no derivative that we have to take here because this is the simple expression. And then we add c for the constant. Final answer, -8 sine t plus c. Now 5 and 6 says use differentiation to determine whether the integral formula is correct. So that means we go back to integration. We're going to integrate instead of, or we're going to differentiate, find the derivative to see if the integral is correct. So that means we have to start at -5 cotangent of x minus 3 over 5 plus c. And we need to take the derivative of this. So I need to take d dx. I'm going to take the derivative of this whole thing. Well, what we do here is, okay, the derivative of cotangent is negative cosecant squared. So that's going to change that to a positive. So it's 5 cosecant squared of x minus 3 over 5. But remember, this is a chain rule, so we have to take the derivative of this. The derivative of this is 1/5. Now, of course, the derivative of c is a constant. So just doing the multiplication here, the 5 and the 1/5 cancel out, leaving cosecant squared of x minus 3 over 5. And we look at that, it says secant squared of x minus 3 over 5. So no, this integral equation or this integral formula was not correct. And so we can say, no, it's not. Example 6. Example 6, well, I'm just going to do the other side and go from there. So I get 8x plus 2 quantity raised to the 4th plus c, and I want to take the derivative with respect to x of that. So when I do that, this is going to require the chain rule. So I get 8x plus 3, or 8x plus 2, the quantity cubed, times the derivative, which is 8, and the derivative of c, of course, will disappear. Oh, I forgot to take the 4 out here. Whoops. Okay. Take the 4 times the 8x plus 2, the quantity cubed, times the derivative of the inside, which is 8. And this gives me 32 times 8x plus 2, the quantity cubed. And that is exactly what we want, because if we look at it on the left, that is exactly what was there. And so yes, this is the correct integral formula. Number 7, we're given this information. dy dx equals 1 over 2 root x plus 3. And we're told y sub 1, or y of 1, equals -1. And we're asked to find the initial value problem. So what this basically means is we're going to have to come up with the value of c and then go from there. So to find the derivative, or to find what y is, since this is the derivative, we need to take the antiderivative. So the first thing I'm going to do is to rewrite this in a user-friendly form. Then I can actually take the integral of this. So the integral will be 1/2, increase the exponent by 1, and then divide by that new exponent, which is very nice here, plus 3x plus c, because look what happens, the 1/2s cancel out, and so x to the 1/2 would be the square root of x plus 3x plus c. But now we're told that y of 1 equals -1, so I should be able to plug in 1 here and set it equal to -1. So if I do that, I get square root of 1 plus 3 times 1 plus c has to equal -1. And so just solving here, get 1 plus 3 plus c equals -1. 4 plus c equals -1, not -4 like I have up there. And of course I would make that final mistake, or just jumping ahead. And so finally, c would equal -5. So what do we want to write? It says solve the initial value problem. Technically, we're there. C equals -5. We've solved it. When it says solve the initial value problem, that's what we're looking for. What value is C? Example number 8. dr dt means r with respect to t equals 5t plus secant squared of t. And r of -pi equals -5. Okay, first thing I need to do is take the antiderivative of this. Well, I'm going to have to add 1 to that exponent, so 5t squared divided by 2. We have to divide by the new exponent. And then I realize, okay, the derivative of what equals secant squared? Well, that is tangent of that. So the tangent of t, if we take the derivative of this, we'd get secant squared of t. And then that has to equal plus c. So here's the antiderivative, or the integral of it. And so we should now know that if we plug in -pi in for t, we should get -5. So that would be 5 times -pi squared over 2 plus the tangent of -pi plus c equals -5. So this is 5 pi squared over 2. The tangent of -pi is 0. Oh, that works out very nice. Plus c equals -5. So c would equal -5 minus 5 pi squared over 2. And this, of course, would be a sufficient answer for c. If we wanted to, we could convert this to a common denominator of 2, and then it becomes -10 minus 5 pi squared, all over 2. Example number 9. Okay, let's see what we've got going on. We have the velocity. We need to think about what that means as far as derivatives and stuff like that. 8 over pi sine 4t over pi. And we're told s of pi squared equals 2. We're given the velocity and its initial position. We need to find the body's position. In other words, we need to find s. Well, the derivative of s is v. So the antiderivative of v would be s. So we need to take the antiderivative of this. And so realize what that is going to mean. We start out with 8 over pi. The antiderivative of sine is a negative cosine, because if we take the derivative of negative cosine, we get a positive sign. So that's the way you need to think that one through. 4t over pi. But since this is a chain rule, we have to take the derivative of this and divide by that. So the derivative of just this is 4 over pi. And plus c. Okay, so let's see what happens here. The 4 and the 8 will cancel to a 2. The pi's here cancel each other out. And so we're left with -2 cosine of 4t over pi plus c. Now here's where we can use this information. S of pi over 2 is equal to 2. So we get negative 2 cosine of 4 pi squared over pi plus c has to equal 2. Negative 2 cosine of 4 pi plus c equals 2. And of course we should remember that cosine of 4 pi is equal to 1. So we get negative 2 plus c equals 2, or c equals 4. And so that's not completely the answer. We know c equals 4, but we are asked what is its position. So our position, s, would be negative 2 cosine of 4t over pi plus 4. And all I did was plug 4 in for c back into this equation, which is our s. Example number 10. A rocket lifts off the surface at an acceleration of 30 meters per second squared. So A is equal to 30. I know that. How fast will the rocket be going 2.5 minutes later? In other words, the velocity. Okay? So what we need to do is first of all look at what relationship does acceleration have with velocity. Well, acceleration is the derivative of velocity. So if we know the acceleration, the antiderivative of acceleration would be the velocity. So that is 30t plus c, where t represents the time. Now we have to think this one through. Right at time 0, how fast was it going? Well, it was going 0. It wasn't going anywhere at time 0. It was launched immediately after, but at that point it was not going anywhere. So in other words, c is equal to 0, therefore the velocity with respect to time is 30t. And then it asks 2.5 minutes later. Now here's where we have to be careful. This is meters per second squared. So this would have to be meters per second. And so t has to be in seconds. So we have to do that quick conversion. 2.5 minutes is, oh boy, 150 seconds. So we need to put in 150 instead of the 2.5. And when we do that, let's see, 30 times 150 would be 4,500 meters per second. That's going very, very fast. And finally, example number 11. Okay, we have the velocity of a body, and it's given this way. ds dt equals 9.8t minus 4. Now realize this should not be a big surprise. S we know is position, so the derivative of s with respect to t, the derivative is velocity. So that's what's given. The velocity is this. Find the body's displacement. Now here's where we have to do a little bit more work than just plugging in values. We're actually going to have to look at the graph and figure some things out. But the first thing, displacement means position. So the first thing we have to do is to find what s would equal. Well, that's not too difficult. Take the antiderivative of this. So that would be 9.8 t squared divided by 2 minus 4t plus c. And so this would equal 4.9 t squared minus 4t plus c. Now we are told that s equals 5 whenever t equals 0. So if I would put S of 5, that would be 4.9 times 5 squared minus 4 times 5 plus C, and that would, and I'm doing that exactly wrong. These shouldn't be 5s, these should be 0s, because the time is 0. So 0, 0, and that will equal 5 at this point. So that tells me 0 minus 0 plus C equals 5. Or in other words, S of t is equal to 4.9 t squared minus 4t plus 5. So there's S. Now we need to find what is its total displacement from t equal 3 to t equals 7. Now in order for this to make any sort of sense, we need to look at, okay, what does the graph actually look like here? Because if it changes directions between 3 and 7, then we have to figure out, okay, where does it change? And we have to figure out from there, from 3 to wherever it changes, and from wherever it changes to 7, so on and so forth. So what I'm going to do is I'm going to graph this real quick. And I'm interested between 3 and 7. As soon as my calculator will come up, and I apologize, I didn't really think I was going to need this calculator, but I forgot about this very last problem. Okay, so I'm going to start out with my normal viewing window, negative 10, 10, 1, negative 10, 10, 1, clear out any equations that I've already had, then I'm going to put in 4.9x squared minus 4x plus 5, and then go ahead and graph it. And once again, I'm interested between 3 and 7. Well, 3 is here and 7 is here, and it appears to be a parabola, and that should not be a big surprise. It is a parabola, and so there's no turnaround time. So basically all I have to do is plug in the values and see how much did it travel between the two. So with that in mind, first thing I need to do is find S of 3. And unfortunately I'm going to have to go back and use the calculator here. But it'll be 4.9 times 3 squared minus 4 times 3 plus 5. And so that'll be 4.9 times 9 minus 12 plus 5. And 4.9 times 9, let me see if I can do this in my head real quick. 44.1 minus 12 plus 5, which equals 37.1. So that's what S of 3 is. That's in essence where we started. Then I need to find what is S of 7. S of 7 equals 4.9 times 7 squared minus 4 times 7 plus 5. That'll be 4.9 times 49 minus 28 plus 5. And let's see, this all equals 217.1. So this is where we end. This is where we start, this is where we end. So the total displacement would be the difference. 217.1 minus 37.1, which is 180. 180 what? Well, we are talking, aren't given any measurements, so it's just 180 units is how far we travel during that time.